Right, a little bit more of a complicated rational inequality. Okay, so remember, we've got this x plus 1 over 2x minus 4, but it's not set less than equal to 0. It's set the less than equal to 1. So I've actually got to take away 1 from both sides, because I need it looking like this. Okay, so this is why they have this. That's the start of our problem. Okay, right, now there's actually two ways of actually finding the critical values on this. Now still, the first one is still look at the denominator. Okay, remember, this is the one that's not defined. What makes the denominator 0? Looks like x equals 2. Again, you can just set that equal to 0 and solve it, like we did this one. Remember this? Set the denominator equal to 0 and solve it. Okay, so that will give us x equals 2. So I'm going to put 2 on the number line. Okay, so I've got one answer already. Now, two ways to get the other one. So remember, with this one, I just set the numerator equal to 0. Okay, because as long as the numerator is 0, then everything's 0. But with this one, it's more complicated. It's not just a numerator, there's two terms. So again, there's two ways of doing it. The way the book does it is to solve it equal to 0, put everything equal to 0. Okay, remember with this one, I just set the numerator equal to 0. Okay, but here I can't just do that. So I'm going to solve everything equal to 0. And that means multiplying everything by 2x minus 4, the common denominator, the only denominator. Okay, so if I multiply 2x minus 4 by this term, the 2x minus 4s will cancel. I'm left with x plus 1. If I multiply the 2x minus 4 by the negative 1, I'll end up with negative 2x. And negative 1 times negative 4 is positive 4. Remember, this still equals 0. Okay, so I'm going to turn to another slide here, because here it is. Okay, this is how they've done it. They multiplied everything by 2x minus 4. Of course, if we multiply the other side by 2x minus 4, it's still 0. So when we come down to it, we get x equals 5. So again, I would put that on my number line. Okay, and that's what they have right here. Okay, now another way to solve for the other critical value is to literally set this up as a fraction problem. Okay, so in other words, I will end up subtracting a couple of fractions and it will end up looking like just a regular rational. Okay, something over something else. Okay, so it's not two terms like I've got here. So to set this up as a regular fraction problem, I need common denominators. Well, the common denominator, the only denominator, is 2x minus 4. One is 2x minus 4 over another 2x minus 4. So here it is. So the common denominator is 2x minus 4. Again, that's still where this 2 is coming from. Okay, remember, I'm going to solve this and put it down as just one rational, just like that one was. Okay, so x, take away 2x, is negative x. 1 negative negative 4 is 1 plus 4. That's 5. So now I can do what I did. That's 5, okay? Here, by just setting the denominator equal to 0. Again, we already know that's where the 2's come from. The numerator equal to 0, and that's where the 5 comes from. Okay, so there's two ways of solving it. But at the end of the day, we have this right here. Okay, so now we're going to test some numbers. We've got areas between negative infinity and 2, 2 and 5, and 5 and positive infinity. That's what all these solutions are up there. Okay, right, let's just turn to the actual book. Let's cheat a little bit. Right, so here it is. Okay, something less than 2, let's choose 0. Apparently, when we put it into the equation, put it back into here, we end up with a negative. Okay, so we're going to write this as negative. Okay, when we put, let's look, something between 2 and 5, they've used 3, that comes out to be positive. Okay, so this area turns out to be positive. Okay, and finally, something bigger than 5, they chose 6. Easy enough. That turns out to be negative. Okay, let's have a look. So that's negative. Remember, the whole question is less than. It's got to be less than 0. Okay, so let's have a look at it. What area is less? So what area is minus? So this area is going to work, and this area is going to work. Okay, this one is not. That one won't work. Okay, now then, let's have a look at the answer. Okay, here it is. So from negative infinity to 2, which is what we have here, and then from 5 to infinity. But look, this is not exactly what we've got here, right? Because remember, the whole question has got an equal sign in it as well, which means we should be using brackets. That's what we should be using, which is why this has a bracket. Okay, that's why it's got a bracket, because it's got an equal sign is the question. So why doesn't this one have a bracket? Well, that's because this has come, the 2, okay, has come from a numerator. Sorry, a denominator. Okay, we found that 2 from a denominator. Denominators cannot equal 0. So you can't have the equal sign, you can't have a bracket, therefore we write it as a parenthesis. So remember that, looking at denominators. You can never have a bracket there, okay, even though the question was, or has, an equal sign, okay?